Now we're going to do a sensitivity analysis for alpha. Okay, we want to figure out what alpha will give you the smallest MAD possible. Okay, of course you can do trial and error by just plugging in different values of alpha, but there are some methodical ways in which this can be done. One way of doing it, we're going to look at two different ways: data table method and solver analysis. So first, data table. Okay, data table is a command that's available here from what if analysis right there. But before we get there, we have to set up the possible values that you want to try in this model. We want different values of alpha to be entered here, and we want this table to reflect what the corresponding MAD happens to be. So to set up the possible values for alpha that you want to try, what you need to do is to first, okay, the output. So here, the first row of the data table, you identify what the table should be of. So we want this table to be of MAD. So in this column, you enter the formula of the cell reference where MAD is. So that's the first one. So that's reserved for, the first row is reserved for that. So now starting from the second row, then you enter the different values of alpha you want to try. Okay, for example, suppose I want to try 0 and I want in increments of 0.1, okay, like that. So it will increment by 0.1, and you want that all the way going up to alpha equal to 1. All right, so alpha equal to 1. All right, so let's go ahead and format this properly. You don't want to leave it like this, alpha being here aligned to the center and the alpha values aligned to the right. It doesn't look good at all. So we'll do that, and we'll also format so like that. Okay, so now we have the skeleton of the data template set up. So these are going to be our different input values for alpha, and those alpha values must go into this cell, and whatever this cell is, okay, and that value must be reflected right next to it. So you have to start from the row that contains the formulas of the cell reference formulas of the output that you want the table to reflect. So you must start from here, okay, and expand. So if you have more, so like for example, if you have MAPE or MSE, you can have more columns on the data table if you like. Okay. All right. So now you highlight like that, and now you're ready to apply the data table formula. Okay, so right there. Okay, now it has two input cells, because data table can have two inputs. You can have alpha and you can have beta if you like. But right now there is only one input parameter for this model, and that's alpha. And that alpha is arranged in a column. Suppose if you had the alpha going this way and MAD to be right below it, then alpha values will be in a row. Then you would enter the cell where alpha is, which is that, as a row input cell. But that's not the case here. We have the alpha listed in a column, and therefore that is the cell. You have to leave the row input cell blank, because we don't have a row input in this table. We have only one column input. So row input cell is blank. So column input cell, you click that, and you see it populates this. Let me format this first. So it populates the MAD, and look at the formula here. So it inserts what is called a table formula. So the first one is the row input cell, and since we left it blank, it has nothing there, and then a comma, and then D61 is the column input cell. And when you see these squiggly brackets, that means it's an array formula. So array formula means it is entered, the formula is entered into a range of cells. this formula cannot be altered individually because they work together. So if you go and make a change here, like for example, if you say I want to multiply by 2, it'll give me an error because this is not possible. Okay, if you want to do that, you have to do it for the whole thing. Okay, that's called array formula. So now this okay, you can understand what these are when you present this, but this is kind of the first row that we had. We do need it, otherwise the data table won't work. But this is like a sore thumb sticking in there. What to do with it? Well, what we can do is you can right click and hide that row, so that way it won't be visible and it'll be a neat looking data table. Then let's put bottom border back. So you have all of these different alpha values, and we have the MADs. Okay, so what is the minimum MAD? That's what we are after, right? We want the alpha for which the MAD is minimum. Okay. Then do min. All right. Okay. So what if you want that minimum value to be automatically highlighted? So we can use highlight this entire column, and you want the row, the cell that has the minimum MAD to be highlighted. So we can use conditional formatting for that. So highlight the range into which the conditional formatting must apply. So go to conditional formatting. Okay, highlight cell rules. There are some predetermined. You can create your own rule, or there are some implicit rules available for us. We want equal to, right? We want equal to whatever is contained in this cell. Okay, and you can change this. You don't have to use the. There are several. You can have custom format, or you can use one of the predefined formats. Okay, so I'm going to just leave it at that. So it highlights that, and we can also plot this to see what the pattern is. Okay, so and let's edit this. So series name is MAD. The X values are these. Okay, and you don't need for this alpha to go beyond 1. So right click on, so select the x-axis. Okay, format axis. Okay, so here change it to 1. All right. Then axis titles, alpha. Alpha is A with its font changed to symbol. Okay, and this is MAD. And again, too many decimal places, so right click, format, and you can even try to focus here. So we could probably set the minimum to be, say, 8, and then number format, change it to 0. All right. So here is the minimum, which is at 0.2.